Last class, we talked about what happens when scientists want to compare two things. This might be a comparison of a single group before and after the intervention, or it might be a comparison between two separate groups. Now I want to talk about what happens when scientists want to compare multiple things at once. To put it another way, last time we talked about making comparisons with one independent variable, and now we're going to discuss making comparisons when there are multiple independent variables. When we were comparing two groups, we looked at the difference within the groups and the difference between the groups, and ANOVA extends that same approach to multiple groups. When we conduct a t-test, our null hypothesis is that there is no difference between the two groups, and our alternative hypothesis is that there is a difference between the two groups. For an ANOVA, the null hypothesis is that there is no difference between any of the groups. In other words, the null hypothesis for an ANOVA is that all the groups are the same. The alternative hypothesis for an ANOVA is that at least one of the groups is different from the others. This doesn't mean that all of the groups are different from each other, just that at least one group is different. So let's say you read a paper that includes an ANOVA. You know at least one of these things has to be true. They may have had an independent variable with more than one level. For example, they may have had two intervention groups and a control group. They may have had more than one independent variable. For example, they might be grouping participants by both age and gender. Or they may have taken multiple measurements for each subject. For example, they might have measured participants at the start of the trial, immediately after the intervention, and 6 months later to see if the effects of the intervention wore off. If their ANOVA returns a p-value less than 0.05, then they know there's a statistically significant difference between at least two of the values. However, it may not be obvious which two values are different. For that, they need to do something called a post hoc analysis.